Aloha, this is ITS 128, and today is September 27th. Let me share my screen here before I get too confused. All right, so this is September 27th, and so we're around here, I guess. Anyway, what happened was last Thursday, when I was teaching ITS 148, there was no one came. So I just, for some reason, I thought I was teaching 128, and I started teaching the next section of ITS 128. And then about 3/4 of the way through the class, somebody showed up and pointed out to me that I'm teaching back in chapter 12, or back in chapter 5 instead of, I should have been teaching in chapter 15. Anyway, so I gave a 128 lecture last time, and so you can watch that, and I ended up around 5:12 is when 5.12, and then anyway, so the rest of chapter 5 is there, and it's it's a pretty good video and everything. So and so now we're going to do starting chapter 6. So we're going to start chapter 6 today. And is that about where we are? It's 9:27. Yeah, look, we're right on schedule. This is the only class that I'm caught up on. All right, so let's go to the textbook. I was teaching Java today, and this is the Java textbook. It's the same chapters as this textbook, except for I get the languages mixed up, and I ended up having to end that one early. But anyway, so maybe sometime I'll show you some of the differences there. But anyway, so we are in 128, chapter 6, functions. Okay, let me close. Let me find. I want to make sure I do all the challenge activities. Let's see. Let me go to here. 128, chapter 6. All right, let's just start from the beginning here. Okay, so functions is a way of grouping your code, or grouping some code, or if there's some code that you use over again, you're able to take that code and make a function out of it, and then whenever you need to execute that code, then you can just call the function. Okay, so let's say you have a program like this, and you're doing these calculations where you're calculating Celsius, from Fahrenheit, and so this calculation here you do 3 times, and so what you could do is you can create a function, and in this case we're going to call the function F2C, Fahrenheit to centigrade, and the input is going to be the F, and this is the function it's going to perform. It's going to take the F, it's going to do the calculation, it's going to calculate the C, and it's going to return the C. So instead of having this in your main program, now you can have this, where C1 is equal to this function that you created, and the input, of course, is F1. So, and now, of course, one advantage of this is that you save code, you save program space. But the other more important reason is that you avoid mistakes. And see, this is an example of the mistake. Let's say you're typing this in or something. Let's say you're not copy pasting, you're typing it in, and you accidentally type a plus sign there. And then so 1 and 2 are correct, but 3 ends up being incorrect. So that is the main reason why you have functions. If there's any way that you can, if there's some code that's the same or similar in multiple places, you can make a function out of it, repeat it. So make sure you understand this. A function definition consists of the new function's name and the block of statements. So it's you start out with this def word, and then you know, like this. Here you're going to calculate the pizza. So the function is called. Boy, they really got to make it confusing for you, don't they? This is the function right here. This is the function that's called. And so 12-inch pizza is this amount. And so this takes, this is a bad example. Given the following program and this function defined above, I just want to be able to explain this. Okay, so this prints out 12. This prints out the value 12 in one digit to the right of the decimal point format. So that's why it comes out looking like this. And then it prints out inch pizza is, and then it prints out another number, and that's this number. And this is 3 digits to the right of the decimal point format. And then whatever this calc pizza area is, that's going to be a value that's returned. And it looks like it's hard coded right now to be 12. But what I can see happening is that we make this pizza diameter be a parameter, which would go right there. Anyway, that's probably where we're headed here, but let's see, make sure we understand this. How many function calls to this exist? Okay, so it looks like it's twice. 2, is that what the answer is? Yeah, all right. How many function definitions are there? Well, there would be only one, assuming I don't see it up here, but there would be one. Only one, yeah. Okay, so anyway, make sure you understand that. This is calling a function. So this is just a function definition. It doesn't cause anything to be written or anything. It's just the computer reads that and remembers it. It remembers this thing. And then, so this is the first statement that's really executed that does anything. So it outputs say cheese, and then it prints this get face thing. And now this get face is, now we're going to call this code up here to execute. And what this code does is it prints out 2 eyes and a nose and a mouth, it looks like. And that's or no, it doesn't print it out. It sets this variable equal to it, and then it returns that variable. So that's what gets printed out here. You can run this. Did I run it already? Anyway, let's see what this does. See, it prints out that, and then it prints out this. All right, let's do a challenge here. Get pattern 5 returns 5 characters. It does. It returns 5 characters. Call get pattern twice to print in print statements to return and print 10 characters. In other words, I'm supposed to call this function twice, and so it prints out looking like this. So I guess there's got to be a print statement in there. So I guess it can be print get pattern. So it's going to print get pattern, and then it's going to print a new line, and then we're just going to print it again. I guess. Well, that seems pretty easy. All right, so here's another, the return statement. That's how you send back the value. And what happens is this thing here, you recall the right side of the assignment statement. The assignment statement is this equals sign. The right side is an expression which computes to something. It computes to some value, and that value is what gets stored in here. And so when this thing executes, when this thing computes, then it's going to be replaced with something. What's going to be replaced with a number? Well, what number is it replaced with? The 7 is a when it's being called, it's called an argument. This function is being called with an argument of 7, and then this function up here is being executed, and the parameter is 7. So it takes the 7, multiplies it by itself, and then that's the number that it returns. And so what this means is that this thing here is going to be replaced. This thing here is going to be replaced with whatever this thing returns. So this is going to return 7 times 7, which is 49. So this is equal to 49. And so that's why this looks like that. All right. So anyway, that's how that works. Right. Add a return statement. So it returns this. We just look at it like that, right? Return. We don't put the return in parentheses. We put the print in parentheses. So it would just be return with that. All right. So a parameter is a function input specified in a function definition. So in the function definition, it's called a parameter. And when you're calling the function, you call it with an argument. So this, you can step through this. How are you supposed to step through it? Just, oh, you can watch this. This is actually what happens inside. You see, this just sort of sets everything up. It doesn't execute any code, you know, when the first one here. See, so when this executes here, it doesn't really execute any code, but it does check to make sure that there's not any syntax there. So I don't even think it does that. It just sets it up, you know, to be accessed later. And so it remembers that there is a function, that it has a function called this, but then it goes right down here and starts executing this code. This is the first time it calls it. So when this is called with a argument of 12, then that's the first time this is executed, with 12 coming in here. And then at that time, there could be some errors here. And so that's when any errors will be revealed when this thing is executing. I think certain errors. But anyway, so then this thing all executes, and whatever this calculates to be, that is what is returned. And so that is what is replaced right here. And then it's printed out with this 3 digits to the right, this floating point, F for floating point, 3 digits to the right of the decimal point. So it's going to print out, you know, 12-inch pizza, 16-inch pizza. This is the calculation right here, which is this, and then it prints out the square inches, and so that's why it looks like that. All right, so go through this, make sure you understand it. Multiple or no parameters. A function may have multiple parameters separated by commas, or it doesn't need to have any parameters. All right, let's see what this is. Hierarchical function calls. Okay, a function can call a function. So here we have this function being called, okay, and then this thing, okay, so what is this? Well, when this is called, then it looks like this is executed with this parameter here, and then this is executed, and then this is executed. Oh, look, there's another function call here. So this is called, and so that calls this up here. And so this thing executes, blah, 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 calculates circle area, returns circle area, so that's what gets put right here. Whatever that value is, whatever this value is gets put there, and then it gets multiplied by this, and that gets stored there, and then this thing gets returned. Total calories gets returned in place of this, where this was called, which is the first time is right here. So the total calories will be replaced, will be put there, and output 2 digits to the right of the decimal point, and does it twice, and so it ends up looking like this: 2 digits to the right of the decimal point. All right, so anyway, so that's function calls, hierarchical function calls, a function calling a function. All right, what's this? Complete the function definition to return the hours given minutes. Okay, so you input the minutes, you output the hours. Okay, so here we have some minutes, and we're going to have to return, because we're printing it out here. We're printing out 3.5 when minutes is whatever it is. Okay, 2.10. Okay, so we have to print a solution here. I would just say that we are going to return original minutes, and you know, it can be an expression. You don't have to necessarily calculate it beforehand if it'll all fit on one line like this, and it does. So I'm just going to do original minutes divided by 60. And so let's see if that's the answer. I guess it is. All right, what's this one? Define a function, calc total inches. Okay. Def this with the parameter of num feet and num inches. And then colon. And what am I supposed to do? Returns the number of inches. Oh, so, and there's 12 inches in a foot. So if the input is 5 feet, 8 inches, it's going to return 68, because 5 times 12 is 60 plus 8 is 68. So we're going to return num feet times 12 plus num inches. I think that's all we got to do. Well, these are just too easy. Should stop giving you the whole answer. Enter the output of the returned value. Enter the output. This is just, I'm going to do the hard one. You can do the other two. Okay, so what this is going to do is this calls a function called change value with 4 and a 1. So this is a 4, the x is 4, and the y is 1. So it comes down here and it's going to calculate 4 plus 1. That equals, in this case, 5. So result is going to equal 5. So it's going to return 5. So that means this right here is 5. So that must be what it prints, 5. I think. All right, so it's that easy. Okay. Function definition is another function definition. Okay. Define a function called calculate pyramid volume with the parameters base length, base width, and pyramid height that returns as a number the volume of a pyramid with a rectangular base. And so we have this. So we got 4.5, 4.5, 2.1, and 3.0. It prints out this, the volume for 4.5, 2.1, and 3.0. The volume for 4.5, 2.1, and 3.0 is the calculated pyramid volume. So this is the name of the function. So I'm going to copy this. I'm going to put it here. I'm going to I hate to just give you the exact answer. So what I'm going to do is I'm going to open up my notepad, and I'm going to paste. I'm going to type my function in here, and so I'm going to call it def calc pyramid. It's whatever this is. No, I'm going to just copy this right here. Oh, I'm going to copy this whole thing. Copy. And you should try to do this too. So right up here, I'm going to put in this function. I'm going to put in this function. So I'm going to copy this. And that's going to be my def up here. Def that colon. And I'm going to be just to make the point that these don't have to be exactly the same. I'm going to make them different. Width and height. I'm going to call it that just so you can see that they can be different. And then I'm supposed to calculate this thing. So I'm going to return something. I'm going to return some value. I'm going to return area, volume. I'm going to be return volume. Okay. And so up here, I got to calculate volume. Volume, well, here we have it right here. It's right here. Copy. And I'm going to say, it goes right here. Paste it right there. And I'm going to, might as well make this the same as that. And I'm going to say base area. The area of the base must be the length times the width. That must be the area. Does it say that someplace? Ah, here it is. Base area. Just gotta look. So I'm going to say this. Base area. I'm going to say base area equals len times width. And oh, by the way, it's not X, it's asterisk. And this is going to be base area. Oops, I'm going to copy this there. Copy. And that's really what this is. Paste. And then this height is really HEI times 1/3. This is an asterisk. And this is an asterisk. And this is just fine. That's fine the way it is. And so we're going to return, this is a capital V, so return that. And so we got to make sure all these are the same. Len is here, width, height, base area, calculates volume, returns volume, and that's what's going to go here. And so let's test this. LENGTH, and this is going to be the width. And this is going to be the height. And I'm just going to run this. I'm going to save this as, I'm going to save it on my desktop. Right here, I'm going to just save it right on my desktop. I'm going to call it test.py. What a nice test.py. Ooh, do I have that something like that on my desktop already? I guess I must. Doesn't matter. Okay, so now I'm going to open up and I've installed Python. So I got to go. I got to get a CMD. There's a CMD. And I got to go to CD to my, I've got a documents. I think I have to go to OneDrive. CD, OneDrive. There, now I have my desktop here, CD desktop, CD desktop, EIR. There's my test.py. So I can do Python test.py. And first thing it asks me is the length. So I'm going to type in 4.5, and then it asks me the width, 2.1. Then it asks me the height, 3.0, and it outputs that. Well, I think that's probably the answer. So of course you don't want to have these in there. You don't want to have that in there. So you should really get that one. All right. Print functions. Printing from a function. So here's an example of where you just make this function called print summary, and it doesn't return anything. See, there's no return statement. And so it can just sit out there all by itself. You just put it there. It's not going to return anything. It doesn't matter. It's just going to execute. When this thing comes along, it's going to go up here and it's going to execute these statements, and then it's going to be done. It doesn't output anything. Well, it does output anything, but it does output, but it outputs to the printer, not back to the program. So anyway, see here, we're doing this indenting thing. So make sure you click through that. Print operations must be performed in the main program. Well, no, because that's what we're learning here. Oops. No, it doesn't. A void function can have any number of parameters. Oh, you see, these are called void functions. Is it called that? Yeah, it's a void function because it doesn't have a return statement. In other languages like Java, like C#, you actually have to say what is returned. And if nothing is returned, then you say void. You actually use the word void. But anyway, so that's so these are void functions. Void function can have, yes, it can have any number of parameters. A print function must return the value that was output. No, it's just stupid. Calling a print function multiple times. So here's an example of, you have a print function and you pass in something to print. So here you're passing in a word to print. So it prints some stuff, and then it prints the word, and then it prints some more stuff. All right. So this is making a menu. Well, you know, menu like this, where it just prints out something. So here, okay, so we have a variable called quit program, and we start out having it be equal to false, and then we loop here. And each time we loop, we're going to read in something. Yeah, here. So we're going to read in a choice. Enter your choice, and you're going to enter 1, 2, or 3, depending on whether you want gumbo soup, or you want jambalaya soup, or you want quit soup. No, you want to quit. And so here the choice comes in. See, these are functions, you know, we already know about functions. These are built-in functions. This function here, that function in there, that function first prints this out on the screen, and then it waits for the user to enter something in. And so as the user enters stuff in, it collects it in, and once the user hits the enter key, then it's done. And then it returns that value, so that gets replaced with this, but it's a string, so we want to convert it to an integer. So this is an integer function, which takes one argument, and that argument is something other than an integer, and it converts it into an integer. If you put something in here that doesn't convert nicely to an integer, like you put some letters in there, then this function will blow up. There'll be an error. The function will say, oh, well, I can't do anything, and stop. So anyway, so here we check to see if the user entered in a 3. You know, we don't really need to convert this to an integer. We can just keep it characters, put quotes around here, keep it as characters. So anyway, just thought I'd mention that. So anyway, and then so it either does something, it either prints it out, or over here it's going to quit the program. See, so if you order gumbo. Anyway, so that's okay. So let's do this one. Start it out here. Okay, so we have we set this variable equal to 21, and then we use that as the call. We use that as an argument to this print age function. Let's look at the print age function. Takes in this argument, and it prints out you are whatever the number is, and that's it. I'm not even going to type it. Let's do the hardest one. Okay, so here we have this method, and it takes 4 arguments. No, 1, 2, 3 arguments. Username, which comes in as name, user age, which comes in as age, and regular time points plus overtime points. So it adds those 2 numbers together, and that's the 3rd argument. So that comes in as total points. It prints out the name and the age, and then it prints out the name, and then the word made, and then it prints out the total points, and then it prints out the word points, and that's it. And so these are the variables that were initialized before this was called. So what does this print out? It prints out, what's the name? Bob. Is, what's the age? 20, young guy. And then it prints an enter. Okay, so I've done this one. And then it's going to print Bob made 24 plus 7 is 31. 31 points. Enter. Oops. So this is 31 because here we take the 7 or the 24 plus the 7, and that equals 31. So that's the prep. That's what goes in here, 31. And so this is 31. 7 plus 4, 24 plus 7 is 31, isn't it? Let's check and see. All right, very good. All right, what's this one? A function call with a parameter. Okay, so we're going to call this function with these 2 arguments, and so there's got to be a function up here. And what does it do? It prints. Oh, it prints using this apostrophe or this single quote, double quote. So you want to print this out. And with a new line. Okay, so I want to put a function here, def print this. So we have that colon print user feet. Is this going to work? Plus a single quote plus a space plus user inches plus a double quote. So I'm going to do single quote, double quote, single quote. And I'm going to see if this works. I'm going to copy this here. And I'm going to put it over here. Control A, delete, Control V. And I don't need this here. And I'm going to say feet. And I'm going to say inches. And I'm going to save this. And that's okay. It's a comment. And I'm going to run it. See if it works. See, I'm unsure about, this is an integer and then this is a character. I'm unsure about that in this language. It's one of the things that can be different in different languages. I think it's okay. Let me just run this. And it's going to ask for invalid syntax. This is indented once. Maybe there's too many spaces here. No, can't be right. Input feet. Quote, single quote, double quote. What's so invalid about this one? Do you know what's wrong? Okay. Oh, I know. Forgot the end of parentheses. See, that's often a clue. If you notice the arrow points to this thing, it doesn't know what that is, but really it's still trying to process this line up here. It's still trying to process this line, and it's expecting, it's expecting a number of things. It could expect a space and a plus, or it can expect an end of parentheses. But what happened was there's a return, and then there's just another the starting of a variable name, and so that's where so it flags the errors right here. It's because this character here was not expected anyway. So we got to just close that up like that and save. See if it works now. And feet is 5, and inches is 8. And okay, so yeah, so I was, see it. This is an integer, and these are characters. So I think I got to do something like this, str. Well, yeah, I can do it this way. I think I will do it this way. str. So this is one way to do it, I think. Let's see if it is. 5, 8. Yeah, that works. And then, of course, the other way you can do it is you can separate this out. You can go, instead of this, I'm just going to comment this out. You can go print user feet, comma, and equals nothing. And then you can print they can print Yeah, this is humbug way. Then I'm gonna print a double quote, I'm gonna print a single quote, and then I'm gonna print a space, and then I'm gonna print a double quote, and then I'm gonna close that. Oh, I gotta say that end equals nothing. And then I want to say print user inches, end equals nothing. This way. I don't have to do it this way. I can do end equals single quote, double quote, single quote. Oh, I want to print that. Yeah, fine. And then I want to print. I'll just print mine. Print just this. Think. Do I want to print the? Oh, you can do it that way too. Okay. So let's see if this works. Let's save this and run this. 5, 8, and it does the same thing. So anyway, various ways you can do the same thing. Okay, dynamic typing. We're still in chapter 6. Okay. Okay, there's no challenge activities in here. But dynamic and static, okay, it's good that we talk about this. So, okay, a programmer can pass any type of object as an argument to a function. Consider this function, which adds 2 numbers. Okay, we're going to see what happens now. So we have a function called add, and we have this parameter. We use the plus operator as the infix operator, for these two variables here, these 2 arguments. Basically, what we're going to see here is that when you pass integers, it's going to take this and this, and it's going to see that they're both integers, and so this means add them together as 2 number values. Whereas if you call this add function with strings, then these are strings coming in here, and then this is a string, and this is a string, and when you use a plus sign in between 2 strings, you're concatenating them together. See, so if we just go to the end here, we see that the first one prints out, 5 plus 7, and the second one prints out Torah concatenated with Bora. So Python uses dynamic typing. Okay, so to determine the type of objects as the program executes. And that's one of the big differences between languages. It's the type of typing it uses, and languages like Java and C# and C++ and all those are static typing, where at the beginning of the program you say, I'm going to use this variable and it's going to be an integer, and it's got to be an integer for the whole time. You can't just change it in the middle of your program. See here, these languages use static typing, which requires the programmer to define the type of every variable and every function parameter. So you even have to do this with functions, and that's where that word void comes in, because in other languages that use static typing, you have to say what this is, if it's an integer function or if it's a string function. And so you would say, you would put the word int right here, or you'd put the word string right there. You would precede any new definition with its type first. So anyway, all right, reasons for defining functions. Okay, so improve readability, makes sense. All this stuff just makes sense. Improve readability. modular program development. It's easier for, okay, you write this function, you write this function, and then I'll write the regular code, and I can just depend on these other two programmers to write those functions. For example, you avoid writing redundant code. All right, here's a nice challenge activity. Write a function so that the main program can be replaced by simpler code that calls a function miles per hour and minutes to miles. Original main program looks like this. And what you want to do is you want to call miles per hour and minutes. Oh, miles per hour and minutes to miles. How does this work? Okay. Well, anyway, I don't understand this, but they give you everything here you need to know. So I'm just going to take this. So this is some function called this. So first of all, I'm going to copy this. First of all, let's take this. I'm going to copy it, paste it up here. Yeah. Paste colon. And I'm going to keep the variable names the same because it's what's used up here. And I think I might be able just to copy this, copy it, and put it here. Paste. Get rid of this. Oops. I got to print something. It must be this I'm printing. Paste. All right, let's see if this makes sense. This is an input. Wait a second. Well, this is not right at all. This needs to be cut. This needs to be it's here already. Stupid. Okay, so that's there already. And so we have this minutes traveled comes in here, minutes traveled comes in here, miles per hour, hours per travel is here. Okay, so this comes in and goes here, and then that's all we need to calculate this. And this is what we need here, and this thing here comes in here. So the thing you have to make sure of is to make sure that everything on the right side of the equal sign, that everything on this side is defined. You can't have anything on this side that's not defined. You can have stuff it has to be on something gets defined by being on the left-hand side of the equal sign, or coming in as a parameter. Yeah. So here we're reading in miles per hour. Here we're reading in minutes traveled, and then we're going to call this function with these two arguments, miles per hour and minutes traveled. And so they come in here, miles per hour, minutes traveled, and this is calculated, and which goes here, and this goes right down here and multiply. This is calculated, and this is printed out. Is that all we're doing here? All right. The inputs 70 and 100. I'm going to just copy this here. Copy and paste it in here. And I'll put MPH. And this is minutes traveled. Min traveled. And if I save this, and run it. And I'm going to use 70 and 100. 70 miles an hour, that's pretty fast. 100 minutes. It comes out to be unsupported format. Oh, did I do something wrong? Oh, this came out right. But then what happens? Unsupported format string passed to something. I gotta finish this or something, don't I? Is that all I gotta do? How do these go again? Print 2 at point 2F. Point 2F. Okay, yeah, so I don't know. I don't think well, tell you what, I'm just gonna see what this says is the error. Unsupported, okay. Is there something? All right. Do you see what's wrong? Oh, chat. She gotta pay attention. Ending parentheses. Ending. Okay, ending paren. Okay, let's see. On this one. That, this to that. This to that. This to that. Okay, so I have to cheat. This is 6.4. I hate having to cheat with this, but in the interest of time. Oh, stupid. See what's wrong? No, what it is when this is calculated, it's supposed to be returned and placed here. And this is the so yeah, this should just be a return statement. Nope, wait. Miles traveled. Oh, this is minutes traveled. Sorry. Yeah, no, this should be just a return statement. Gotta pay attention. Can't print it twice. See, what happened was when this was a print statement, then this was not returning anything. So when this thing executed, there was nothing that was returned. So we had an empty string that we're trying to print out with some kind of floating point format, and of course that doesn't make sense. So that's why that didn't work before. All right, so that's this is 6.4. All right. Okay, mathematical functions. These are a function is commonly defined to compute a mathematical calculation involving several numerical parameters and returning a numerical result. So here's an example of a function that's where we're defining, which converts centimeters to, inches to centimeters, feet and inches to centimeters. So this makes sense. You read in feet and inches, you come in here, you do this calculation. These are constants. They're just variables that are capitalized, but so they're defined beforehand. So those are filled in there. All right. So we're just talking about an application of functions here. Is there a, here's the conversion, temperature conversion. So this isn't even a challenge or participation, but you should maybe do that. Let's find function calls in an expression. Well, sure, you can do that when you're calling a function. You know, like here we're calling a function. This here, it can be anything. It can be an expression that evaluates to it. It just has to evaluate to something. And so you can put a function in there if you want to, like here. This thing takes 16, calculates the square root of 16, which is 4. And then that 4 is an argument to the function again. So square root of 4 is 2. So is this valid? It should be valid. It's 2. So no, this should not be valid because you got to put something in there. All right, another one. Function call in the function call in expression. Okay, so assign max sum with the greater of num A and num B plus the greater of num Y and num Z. Use just one statement, call find max twice. Oh, I see what we're supposed to do. So first we're supposed to find max sum is the greater of these two plus the greater of these two. I see. So it's max sum is the biggest of these two plus the biggest of these two. And we're just supposed to do that in one function call. Okay, so this finds the max. And so we start out with this thing, and we're supposed to put a solution here. And so it is the max sum is max sum equals the max of num A comma num B plus the max of num Y comma num Z. I think that's right, unless I got the function call wrong. Yeah, okay. Modular functions for mathematical expressions. Modularity allows more complex functions to incorporate simpler functions. So this is more just nesting functions, so it makes it easier to understand in most cases. This calculates the cylinder volume and the surface area by calling a modular function for the cylinder's base. Okay, so the cylinder volume is this thing calculates the cylinder volume, and that would be calc cylinder volume. And this thing takes, you know, the radius, takes the radius and the height, and inside here it calls circular base area. So it calls this thing. And so both of these functions call circular base area, doesn't it? Yeah, this one calls circular base area. So this is circular base area. So anyway, all right, let's see what this is. Define a function calc pyramid volume with parameters base length and base width and pyramid height that returns the volume of a pyramid with the, didn't we just do this one? Calls the, so first, okay, so I'm going to make a base function, a function called calc base area first, I guess. Okay, so, oh, here's calc base area. And now I'm supposed to make a def. This one, yes. So right here, I'm going to put def this, which is going to be this. So I got that. And so the first thing I got to do is lengthen base height. Okay, so let's volume is this. Paste. That's the volume. The base area is this though. All right, so let's get this right. This is going to be this. Copy. It's going to be this times height. It's height. Width is just width. It looks like it's this. And length is just this. So we have the length and the width coming in, and that's going to calculate this base area. This base area using this method, and then this is going to calculate, and I can just, oh, this is a times, and I can just return this. I'm just going to return it. I can do that. Be careful with integer division. Okay, well, how do I be careful with integer division? If I do this, no, I don't need to do that, do I? I'm going to see if this works. All right. Function stubs. Okay, this is for debugging. Is there any, there's no, this is 6.6. Okay, so when you're writing your code, and if it's complicated, you may want to use function stubs. And what that does is basically, you know, you're gonna, you know, you have to write a function, but you're not ready to write the function yet because you're writing some other stuff. And so you just put that there because you need to do this. You know, you often what you do is you do top-down stepwise refinement. So you write the top code first, and then as you call your main program code is going to call functions, And so you write your main program code first, and for the functions, you just, and you want to debug them. So your code's got to work. You know, your code has to execute without any syntax errors or anything. So you may just put the word pass there to, so there won't be any syntax errors, but of course it's not going to calculate anything. The other thing you may do is you may just return some value. You say return 5, and so you know this calculation will always be wrong, but at least it'll return something there. So then this thing will be assigned a value, and then you can see that this part works. You know, so that's what function stubs perform no operation. So here's another way that you can do it. For a function stub, you just put in, you know, a print statement that says fix me. You got to finish the steps to calories. Function here, stopping the program using a non-implement error. In a function stub, you can do it this way, where once you get to the point, it's just gonna raise an exception. And so it's going to stop, and it's going to say, you know, that this was the exception that was raised. Are there any, there's a challenge here? Okay, there's a challenge. Let's see what this is. Define stubs for the functions that and that. Each stub should print fix me, followed by a new line, and should return -1. Each stub must also contain the function's parameters. Okay, so we're going to have a function stub up here called def get user num, and get user num is going to have golden. I guess we're going to just input. Oh no, we're not gonna. No, we're not gonna. We're just gonna write a print. Pick. Print this. And return -1. Compute average. We need one for compute average also. So I'm just going to do this. Copy paste. Compute average. I'm going to put this. Compute average. And be sure to fix compute average. Might be all I have to do. I don't know. Let's see. Well, that's nice. All right. Functions with branches and loops. Okay, so of course, functions can have branches and loops. Kind of silly to even have a whole section on this, but this thing calculates the eBay fee with the selling price. And according to this formula, if the selling price is less than 50, this is what it is. If it's between 50 and 1,000, it's this. If it's over 1,000, it's this. All right. So just make sure you understand what's going on. You should be able to understand that. Numbers program with multiple functions. Interesting. What are we supposed to complete this or something? Or we're supposed to finish them? All right. Well, you can finish them. There's no You don't get anything for it, but so basically, I guess you'd print all the. So what happens when we just run this right now? It doesn't do anything. Oh, here. Okay, so the numbers are see, print comes in, numbers comes in. It's a list. So I guess you can do for num in numbers print num and equals no, this should come afterwards. And supposed to finish this, huh? It's weird. This doesn't look like it's going to work. All right, well, let's see. Well, I got the first one pretty good, except for why? Oh, it's funny that it does. Should we put a variable in here or something? I guess we could. So I'm going to do it this way. I'm going to do s equals nothing. For num in numbers, s equals s plus a space, no, a space plus s. And then I'm going to say print I'll just do this. It's, and I'll do this. All right, what does this look like? S equals that. S equals that plus that. STR. Wait a minute. Ah, I'm doing this wrong. Stupid. And num. What I'm doing here. It should be plus equals. Okay. Take S. Append the number, the next number plus a space onto it. All right, so that's that one. And then, of course, after you do this, it's pretty easy to do the odds and the evens. Do the same thing again. For the odds, you can go if num mod 2 equals 1, then do that. That'll do the odds. And then you can put the S here, comma S. And for the negatives, you can do same thing. Copy this sort of thing, except for instead it's going to be if num is less than 0, then do that. Comments. See if this works. All right, that looks pretty good. Is there a challenge in here? Let's just do these challenges and then I can be done. This was okay, and then we can do. I'll finish up the stuff, other stuff later. Okay, so let's do these challenges over here. Okay. Output of functions with branches and loops. I'll just start. Okay, so first it's going to print, what did you say? What did you say, question mark? And then it's going to say, oh, wait a second. Let's do this. Okay, first it's going to say, this is the argument, and if the length of the message is greater than 8, it's going to print too long. So this is going to say too long, and the next one is going to be high, so then it just prints the high, and it does print return. Pretty good. Let me look at this one here. Okay, so we call this function print selected numbers. That's this one. And so this executes, we're going to read in some numbers. Oh, no. We're going to execute this function, which is this function. And so what that does is it reads in all of this, reads in all the input, stores it in there. It initializes a list to be empty, and then it loops through the user input, split on spaces. So it loops through token. Each one of these is a token, this one, and this one, and this one, and this one, and it appends it appends the integer version of the token onto values, and it returns values. So values is going to be a list with these integer values in it. And so we have just completed this. So that integer list gets stored there. And then we loop through each number in numbers. And if number is greater than 6, then we print it with a return. So is 16 greater than 6? No. So it is. 16 is greater than 6. Is 6 greater than 6? No. Is 9 greater? Yeah, 9 is greater than 6. Not 5, not 4, but 14 is. All right. Very good. Okay. What's this one? Define a function called print popcorn time with bag bounces as the parameter. So we're going to have this, copy def this, colon, and the parameter is going to be bag ounces, okay. If bag ounces is less than 3, then print too small. If bag ounces is less than 3, print too small. If it's greater than 10, elif. Bag ounces is greater than 10, then print too large. And the last thing is elif. If, oh, do I need some colons? No, elif colon there. No, just else. Print 6 times bag ounces. Print that followed by the word seconds. Remember that print automatically adds a new line. All right, let's see if this works. Okay, that looks like it worked. Okay, write a function print shampoo instructions with parameter num cycles. Okay, so we have a function called print shampoo cycles, that's that, colon, and the parameter is num cycles. And we're supposed to do, if num cycles is less than 1, print too few. If num cycles less than 1, print too few. Otherwise, if num cycles, we got even LF. Num cycles is greater than 4, then you need to print too many. Otherwise, you want to print a number, lather and rinse. Okay, so else for cycles in the range of num cycles, I'm going to do I'm gonna do part of this, and then you're gonna do the rest of it. Print C colon quote. Oh, I can just do this. Lather and rinse. Period. And then print done. Oh, wait. No. And print done here. There. Print. Okay, so so this isn't going to be quite right. Because instead of printing 1 and 2, it prints 0 and 1. So I'm going to leave this for you to fix. You got to fix this somehow. 2 ways you can fix it. You can make the range go from 1 to 2, or start at 1 by changing what's inside here. Or you can leave what's inside there and just change this here. Okay. All right. Let's see. It's 2:56. I guess we're done. 6.8 is where we ended. All right. Functions are objects, common errors. Okay, so I think we can. We don't have too much left to finish. So, all right. I may make a separate video for next time. So I've covered up to 6.7, 6.1 to 6.7. You have any questions? I will see you. See you next week. Thanks for watching.